Okay, today we're going to start something that's probably new for many of you, logarithms. First thing I want you to look at this part that I have circled in the box. The logarithm of a number to a base is equal to a power. You need to totally memorize that. The logarithm of a number to a base is equal to a power. So when we talk about the log, we're talking about the power of whatever base I'm using. Now notice if you don't write the word logarithm, it means the number is your base raised to your power. Okay, let's put some numbers on it and let it make sense. The logarithm of 16 to the base 4 is 2 because 16 is 4 squared. Notice the power. 2 is my power, that's my logarithm. Now, the logarithm of 16 to the base 2 is 4 because 2 to the fourth power is 16. The power is the logarithm, but it depends upon the base that you use. If you'll hit the LOG button on your calculator, the log of 16, when you hit the LOG button, is going to be 1.2041. If you will raise 2 to 10 to the 1.2041, you'll get 16. Maybe not exactly 16 because it's rounded off, but it should be 15.99. Now, there's another button on your calculator. The logarithm of 16 to the base e. Use the LN button. And it's going to give you a 2.772 for the power. Because if you raise e to the 2.772 power, then you will get 16. Now, in section 6.7, I believe it is, we're going to look at e and see where that really came from. But right now, we're simply going to use it on your calculator. Okay, now we're back to that I emphasized a while ago. Memorize this piece right here. Okay, let's take a couple more. The logarithm of 25 to the base 5 is 2 because 25 is 5 squared. The logarithm of 8 to the base 2 is 3 because 2 cubed is 8. Now, if I tell you that the logarithm of 49 to some base is 2, you can figure out the base. Of course, and that one you probably already got it in your head, but let's look at it. 49 would be the base raised to the second power. Well, we can go back to what we learned in second class, take the square root of both sides, and this says that my base has to be 7, because if I use a base of 7, then 7 squared is 49. Let's suppose I don't know what the number is. The logarithm of some number to the base 4 is 3. Well, putting it in exponent form, that means that my number, which is x, is equal to 4 cubed, and this would give me 64. Log of 64 to the base 4 is going to be 3. Okay, let's look at a logarithm graph. Now, your calculator will actually draw the logarithm graph, but it is drawing it and using base 10. So since it used base 10, I'm going to use 10 for our numbers here. The logarithm of 1 to any base is 0. Punch that into your calculator. Just hit log of 1, and it's going to give you 0. And the reason for that is that any number, here I'm going to take 10, any number to the 0 power is 1. So keep that in mind. Now, if I use 10, the log of 10 to the base 10, the power would be 1. The log of 100 to the base 10, the power would be 2. The log of 1,000 to the base 10 is going to be 3. Now watch this. The logarithm of 1/10. Be careful how you put it in your calculator, but it's going to give you an answer of -1. That means that the power can be negative. And the power is going to be negative if your number is a decimal. The logarithm of 1/100th would be -2. Now, looking at that from a graph, the logarithm of 1 is going to be 0. The logarithm of 10 was 1, so this is 10 to the first. And then over here, we run it on out, and when it's 100, it's 2. And then when we come back here, the logarithm of 1/10 was -1, and the logarithm of 1/100th is -2. Now, do you remember when we drew those exponent graphs, y is equal to 2 to the x and so forth? They all had a horizontal asymptote. Well, we're going to learn that the logarithm function is the inverse of the exponent function. So the logarithm graphs are all going to have a vertical asymptote. In this particular case, the vertical asymptote is the x-axis. Try it on your calculator. Hit the log of 0 and see what it tells you. And it's going to tell you error. You can't do it. Okay, so let's draw the graph of the logarithm of x minus 4. Now, I'm going to be cute with the numbers that I choose because we want them to come out real nice and convenient. The first number I'm going to use is 5 because 5 minus 4 is 1. And we know that the logarithm of 1 is 0. The next number I'm going to use is 14 because 14 minus 4 is 10. And we already know that the logarithm of 10 is 1. So when I let x be equal to 5, my y came out to be 0. When I let x be 14, my y came out to be 1. Now, we're going to let x be 4 and 1/10. 4 and 1/10. And you subtract that from 5 and you get 1/10. And the logarithm of 1/10 is -1. So that's this point here. I'm just trying to make my point. Look at this point right here. 4 and 1/10 is just to the right of the vertical line, x is equal to 4. So my vertical asymptote for this thing is x is 4. The vertical asymptote is x is equal to 4. The vertical asymptote on this one was x is equal to 0. It's easy to figure the vertical asymptote. Whatever makes this quantity in parentheses 0, that's going to be your vertical asymptote. Okay, let's solve some log equations. Okay, if I give you the log of x to the base 6 is 2. Remember, you can write it in exponent form. And when you write it in exponent form, it's the number is the base to the power. So this says that x is 6 squared, and 6 squared is going to give us that 36. We can soup it up a little bit, but it's still the same song and dance. Let's get the logarithm of 2x plus 5. And let's use base 2, and let's let it be equal to 2. Okay, so my number is what is in parentheses, which is 2x plus 5. My base is 2. In this particular case, my power is also 2. And I'm keeping it simple so that my numbers will come out even. 2 squared is 4. So 2x is equal to 1. So x is equal to 1/2. better try that again. X is equal to minus 1. So that says my X comes out to be minus 1/2. Now look up here. If you plug that back in, 2 times minus 1/2 plus 5. And that gives me minus 1 plus 5, which is 4. And the logarithm of 4 to the base 2 is going to be 2. Oh, that's a little bit harder. The logarithm of 324. And this time I don't know the base, and it is equal to 2. All right, so 324 is equal to x squared. So we drop back again to that second lesson of class, which is 324 is the square root of x squared. So the square root of x, the square root of 324 is my value of x. Let's talk once more about drawing that logarithm graph. Let's draw the graph of the log of x minus 6. And we'll go ahead and use base 10. You need to keep this in mind, that if you don't write the base, if you just write the word log down, you're automatically doing it in base 10. So we're going to draw the graph of y is the log of x minus 6. Okay, and you can let your calculator draw that graph. In fact, you can use the table mode on your calculator to get these points, but we're going to get the points ourselves. First of all, let's talk about the vertical asymptote. We said earlier, whatever makes it into parentheses 0, we can't use. So x is equal to 6 is my vertical asymptote. So that means then that automatically we can come over here and we draw us a vertical asymptote at x is equal to 6. Now let's make our chart. The first number I'm going to use is x is 7, because 7 minus 6 is 1, and we know that the logarithm of 1 is going to be 0. So that says that when I let x be 7, my y is 0. This is my vertical asymptote. We've got that first point. Therefore, we can make the sketch of that graph. It has to look like that. It has to approach this vertical asymptote, and then it runs on out into. And as I said, you can use your table mode in order to be able to get more points on it if you want. The point that in the old days when I give the written test, I had to show this point right here where it crossed the x-axis. Okay, let's talk about some more things. And another thing that they're going to ask for in your homework is the domain. Well, the domain of this thing right here is x is greater than 6. Now, that doesn't say that I can't use something just a little bit more. I don't have to use 7 as my first point, because I have to use 6 point something in order to be able to get these points where I have the negative value. So my domain is x is greater than 6, and it's easy to figure that. Whatever your vertical asymptote is, that's also going to let you know what the domain is going to be. Next lesson, we'll talk about the fact that the logarithm function and the exponent function are inverses of one another. And you'll see that, I think, particularly if we look at the graph. So good luck with section 6.4.